Hello friends, welcome back. My name is Suhail Khan and I'm a Cisco certified trainer. And today in this video, I'm going to show you the switching. We are into a lecture number 10 and till lecture number 9, I have finished the routing process which we call the RIP OSPF, EIGRP and static routing. And today in lecture number 10, we are going to start our switching practicals. Okay, and that is also in full in-depth knowledge. And today in this practical, what we are going to learn, we are going to learn how a spanning tree avoids switching loop by blocking one path, how to check spanning tree protocol configuration, how to make a route switch as a root bridge, how to configure RSTP, and how fast RSTP convergence. Okay, so this thing I'm going to show you practically each and everything. And if you are a new subscriber or if you are a new viewer, so don't forget to like and subscribe the channel. And for online training, you can contact me. This is my number. All right, then this is my email address. So let's start the practical without wasting the time. All right. So this is a Cisco packet tracer, and in Cisco packet tracer, I'm going to show you the spanning tree practical. All right. All right. So this is Cisco packet tracer, and in Cisco packet tracer, I will take one switch. Okay. So this is the 2960 switch. Just click here and take one switch, and just click here, take one switch. And don't forget to watch the video till the end, because in this video I'm going to show you each and everything step by step, and in that is also in very in depth. So don't forget to watch the video till the end. And how you feel about my videos, please comment in a comment section. All right, so this is the two switch, and let's say I am adding a two link between the two switch. All right. One link and another link. So now what happen when you connect the two link between the two switch? So here STP will work. The spanning tree protocol. So what is spanning tree protocol do? Spanning tree protocol, whenever see a two link between the two switch, so it will block one link to avoid the switching loop. And here's how it going to be happen. See here in this video. Now what happening, STP is selecting the root bridge and non-root bridge. That is I am going to show you in this practical only. See, this switch is the root bridge. Now how come I know that this switch is the root bridge? Okay, so it is a symptom if you properly learn the theory. Okay, so in theory you have learned about that. The root bridge is the switch, okay, with the highest with the lowest bridge priority, and all the ports of the root bridge are in a forwarding mode. So by physical appearance, I came to know that this switch is the root bridge because no port is in blocking mode, every port is in forwarding mode. And this is the non-root bridge. Why? Because one port is in a blocking mode, and one port is a forwarding mode. See here, this is a forwarding mode and this is in a blocking mode. Okay, so let me show you how to check the configuration. So what happens when you connect the two switch with each other? Spanning tree protocol select one switch as the root bridge and one switch as the non-root bridge, and on the non-root bridge it block one path and it open only the one path to avoid the switching loop. All right, now let's check. First I'll show you the root bridge. Just click on the root bridge and go to privilege mode, enable, and the command is show spanning tree protocol. And let me configure the host name also so that you will not confuse. Switch 1, okay, switch 1, and the command is go in privilege mode, show spanning tree protocol. So spanning tree is the command. All right, and this is the root bridge. So now the question is how come, see, from the physical appearance I came to know that hey, this is the root bridge. Yeah, because all the ports are in a forwarding mode, right? But hey, what about the configuration? Because in exam they give you question like this: Okay, how do you identify this is the root bridge or not? It is very simple. If this is a root bridge, it is clearly written on the root bridge that hey, this bridge is the root. All right, this is the first symptoms, and the second symptoms is the switch with the root bridge, the switch which is a root bridge switch. Okay, so all the ports are in a forwarding mode, and all the ports are designated port, and see, ports are designated port and mode are forwarding mode. There are five mode: disable mode, learning, listening, and forwarding, right? And in port like designated port, blocking port, all these things are in a theoretical part. You can read the theory like whatever in which class you are going, or I can give online training also if you want. All right, so all the ports are in a designated port and all the ports are in a forwarding mode. So this is the another symptoms to make sure that hey, this is the root bridge, and this is the priority number, because every switch has a priority, and the switch with the lowest bridge ID and lowest priorities become the root bridge, but every switch has a same priority 32768. So if both the switches are having a same priority, then election goes on MAC address. See, this is the root bridge, and its MAC address is 001 and like anything. Okay, 9551 and all. If I show you the non-root bridge configuration, this is the non-root bridge. By physical appearance, I came to know that one port is in blocking and one port is in forwarding mode. So I'll go to non-root bridge. All right. I'll go to non-root bridge, and on non-root bridge, I'll go in. First, I'll go in global config host name. I'll give host name is switch 2. All right, so now here I want to check. So what is the command? Show spanning tree. All right, see, this is a non-root bridge switch. Okay, and in non-root bridge switch, the first information which is shown, this information is of root bridge. This is the non-root bridge, and it is showing that hey, the above switch configuration is of root bridge configuration. The root bridge priority is 32769, and my priority is also 32769. But my MAC address is higher, which is 005, which is higher than the root bridge, because the root bridge MAC address is 001. So the root bridge MAC address is lower than mine MAC address. So that is why switch A or switch 1 is the root bridge, and I am the switch 2 is the non-root bridge because of my MAC address. All right. So this is how you can check the STP configuration. So we have checked the how STP avoid the switching loop by blocking one path, how to check STP configuration, how to make root bridge. Okay, yeah. So this how to make root bridge. So now I want to make this non-root bridge as the root bridge. Okay, so you can do it manually also. So what is the command? I'll show you. See here, just click on the switch. All right, go to configuration mode. This is the non-root bridge switch, and I am making this switch as a root bridge switch. Okay, so the command is spanning tree VLAN 1, spanning tree VLAN 1 root primary. So by giving this command, what is happening after giving this command? The priority, which is currently your switch priority, is 32769, and this is non-root bridge. How come I came to know from inside? The non-root bridge is the non-root bridge is the switch, is one port in a blocking mode and another port in a forwarding mode. All right. So what happen after giving this command root primary? So when you give this command on a switch that hey switch, I want to make you as a root bridge, and now you are the primary root bridge, it means it will reduce the priority by 2 times 4096 and 4096. Okay, so now see, now the election will happen, and focus here. Now this switch becomes a root bridge. Now the election is happening between two switch via hello packets, and they are exchanging the hellos with each other. Okay, so now this was the root bridge, so now this becomes the root bridge. Now see, just focus here. It will take some time, and at the end this switch becomes a root bridge because of that command. Just watch. See, now both the ports are up now. Okay. Earlier it was a non-root bridge and it was a root bridge. So now I forcefully make this switch as the root bridge. Okay. So when I click here and let's check the configuration now. Show spanning tree. See here. Now this bridge is the root. All right. Now switch to this is switch to. Now this becomes the root bridge and its priority which is less by 4096 two times. When you type primary it is less by 4096 two times, and when you give secondary it less by 4096 one time. Okay, so this is how you can make a non-root bridge as a root bridge with the help of this command spanning tree VLAN 1 root primary. Okay, but the in spanning tree convergence is very slow. Let me show you. Let me show you. Just take one computer. All right, and here take another computer and connect the link with each other. All right, fast Ethernet. Okay, and just I'm connecting the two computers to show you the problem with spanning tree, because in spanning tree convergence is very slow, because if this link is goes down, so the other link take 50 seconds to come in forwarding mode. All right. So let me give this PC an IP address 10.0.0.1, and all right, to show you how it is like not good. Spanning tree white is not good because it is by default enable also. No need to configure STP. It is by default enable on all Cisco switches to avoid the loop. So now both the PCs are connected. So what I'll do is I'll just open the and I'll just customize this thing. Okay. I am on this PC. All right. Now I will do ping 10.0.0.2 space. In Cisco packet tracer, if you want continue ping, then you will type -t before that IP address. In real time, we are giving after. See, now I started the continue pinging from one computer to another computer. Okay. So now what I will do, I will just just delete the above link. The upper link, I will delete the upper link. All right. I will just delete this link. This link I want to delete. See how much time it is taking. Just take this cross sign no. Okay, and with the help of this delete, I will delete this. When I delete this, see, now here output will show that request timeout, and it take 50 seconds to come up. See, this is the drawback of spanning tree protocol, because we are connecting two links so that if one link goes down then another link take the charge, but here it is not happening like this. Then so that is why STP is of no use. See how much request timeout is coming. It take 50 seconds. See, now the reply is coming, because so what about this timing, right? What about this timing? So this is not a good thing. This is not a good thing, because we connect two link each other. We connect two link by typing Control Z. I again added the link. Okay. So this is the drawback of spanning tree protocol, because hey, we are connecting the two link for redundancy purpose, because if one link goes down then another link take the charge of that link, right? But it is not happening like this. So that is why in spanning tree protocol convergence is slow, and due to this slow convergence this spanning tree protocol is modified to rapid spanning tree protocol, and that rapid spanning tree protocol you have to configure. All right, so now this time I'm showing you how to configure rapid spanning tree protocol. Okay, and how fast is the RSTP convergence. See, so now see how to configure RSTP. So I will go to this switch 1. Okay, in configuration mode command is spanning tree mode rapid -pvst. All right, In the same way, I will go to switch 2 as well, and I will give command. I'll go in global configuration mode, spanning tree mode, rapid hyphen PVST. So now on both the switches, I have configured the RSTP now, and RSTP take less than 3 seconds. All right. So let me show you once more time. I'll just open the CMD. Okay. I'll just open the CMD of this computer. Okay, and I'll do a continue ping. Okay, in Cisco packet tracer you have to write hyphen T before the IP address. In real time it is written after the IP address. So now I started the continue pinging. All right. Okay, now it is continue pinging. Now what happened? Now what happened? If currently RSTP is running, now if I delete this link, or if this link goes down, then immediately this link will up. Okay, so let me show you this thing. See, the ping is happening. All right, just focus here on the orange link. As soon as I delete this link, this orange light becomes the green light and no packet will drop. All right, see here also. Okay, the ping is also working here. All right, and see, I'm deleting this now. Just focus here. 1, 2, and 3. See, immediately it becomes up. And here also there is no drop. See, there is no drop. Okay, so this is the beauty of RSTP. So what we have learned in this practical, we have learned about how to configure STP, how to check STP configuration, how to make root bridge, and how to configure RSTP, why RSTP is modified because of STP slow convergence, and how fast is RSTP convergence is. And if you are a new subscriber and you don't know how to watch the remaining parts, then here how to go to my channel. Just go on YouTube and click on CCN Expert, because if you want to be an expert, learn from expert, and this will take you to my channel. This is my channel CCN Expert, and don't forget to please subscribe the channel and hit the bell icon for the latest update. And here I am making the playlist. Okay, so here you will get the playlist new CCNA 200-301 in English language, as well as if you are understanding Hindi language. So for Hindi user also there is a playlist I have created. All right, see here, new CCNA plus I have created the Python also, Python in Hindi and Python in English language. All right, so here's all the playlist. You will get all the videos from here. And how you feel about my video, please comment in a comment section. And for online training you can contact me. This is my WhatsApp number. Thanks for subscribing my channel. And